Good morning, everyone. Welcome to the parallel session on climate and energy. For that session, we are having four nice presentations that we will see later. And just as a short overview on the session itself is just, as you know, energy is one of the core infrastructures, on critical infrastructures on our system. So we really need to take care of it and see how the climate and its impact on the cities has really an impact on cities. So what we want to do with that session is really to show how we can handle it and how can we, regarding the urban planning and resilience, let's say, actions, we can improve that behavior. Okay, so we will start now with the presentation entitled Circular Urban Systems Towards a New Concept for Urban Planning and Design from Georg Hubmann. Georg is a research assistant and doctoral candidate at the chair for urban design and sustainable urban planning at TU Berlin. His main interest lie in the nexus between climate change and urban space. So Georg, floor is yours.
Thank you very much for the introduction, and greetings to everyone who is listening. And also thank you for having the opportunity to be able to present at the URCC platform. What I will present today are early results from my PhD, from my ongoing PhD research. And I talk about circular urban systems and how a resource-centered spatial planning could look like that addresses the resilience of cities. And I want to start, first I need to share my presentation. Here you go. And I want to start with two reminders. The first one is about climate change. Climate change is a substantial threat for our cities. So we know today that climate phenomena such as urban heat islands are strongly related to the human-built environment and can possibly contribute to destabilizing the organization of it. Examples are floods, an increase in heavy rain events, and electrical grid blackouts, etc. What this diagram shows is that we are at a critical point, and many cities have discovered this and are designing strategies for it. What kind of strategies will be a focus of this presentation? The second reminder is about that we live in an era of consumerism, and how we use resources follows mostly a linear logic. So the consumption of resources has been sharply increasing. Not only the world population has doubled since the 1950s, there are also 20 times more cars, and for example, a lot more water use. Funnily enough, also the number of McDonald's restaurants seen here correlates with that tendency. At the same time, the CO2 concentration in the air has reached record levels. So when we talk about city systems, we talk about systems of scale. That means that quantitatively, there's a lot of energy, a lot of waste to deal with on an everyday basis. So cities are in a dilemma. On the one hand, they are the focal points of development and centers for population growth. On the other hand, they account for around 75% of the world's CO2 emissions. And here starts, this is basically where my research interest starts, at the crossroads of circular economy and city planning. So I focus on urban flows and their infrastructural systems and how to address a more sustainable use of resources in cities. My argument is that there's an intrinsic link between urban resource flows and the production of space. So the way resources are used and are managed in cities has effects not only on the urban metabolism, but also on spatial configurations. Circular economy, CE, is seen as a way to help solve cities' complex sustainability challenges by transforming their urban metabolisms and by applying looping actions to material flows. But when applied at any urban scale, it is criticized that it's heavily focusing on technological change and is largely omitting social aspects. And there's no clear evidence whether CE initiatives, as they are increasingly formulated as urban policies, provide environmentally sustainable results. So how can the relationship between circular economy and city planning be characterized? There are conceptual touching points, as for example, the practitioner orientation, the systems perspective, and both concepts are multidimensional and interdisciplinary. The main difference, though, is that the circular economy is focused on resources and spatial planning on space, and that circular economy is mainly focused on the technocratic goal of closing loops, whereas city planning has open-ended goals, such as addressing the triple bottom line of sustainability. Still, city planning, and I explicitly refer to spatial planning, is key for an enhanced circularity because it affects relevant urban strategies such as mobility or construction. It can provide spatial proximity to close energy and material loops, and can promote regulations as, for example, the reuse, recovery, or repair. So with that in mind, I was looking at two case studies and the literature and came up with a conceptual framework called circular urban systems that gives guidelines how to design a resource-conscious urban space. This concept is understood as the glue between a resource-oriented strategy and the spatial considerations necessary for urban planning and design. I found that a common place of urban transformations dedicated to circular economy is the goal to create circular urban metabolism. And this can indeed look like how it was drawn here by a student last semester. So basically different infrastructural components linked with urban flows integrate with different other components with space and actor networks. So my proposed framework suggests that that the logic of design is changing in the sense that you would start with an assessment of the available resources, the available local resources, before you develop ideas about the place. It would require a contextual approach across the boundaries of the plot, the street, the district, and to the wider region. So the goal is to reuse waste products, including, for example, excess heat from industry, look for cascading effects, and keep materials in a loop as long as possible. In other words, this means to develop areas and the infrastructures based on the principles of decentralized, interconnected, and polycentric systems. This requires a re-evaluation of traditional values of urban planning and design, including the approach to infrastructure, the creation of integrated networks, the role of public space, and the scalability of solutions. And it would also require an integrated vision and management of the different existing planning tools at the city level and appropriate policy instruments as well as participatory elements. This sounds quite like a lot, but there is projects that have achieved this, and this is also where I learned a lot of these things from. Still, there is a considerable gap between theory and reality, but I will try to illustrate these reflections with two case studies. The first one is in Berlin and is called Roof Water Farm. It reuses gray and black water from an urban block, so not just from one building, but 2 or 3 connected buildings, and collects all the rainwater from the roof of those buildings for, on the other hand, growing vegetables, herbs, fish, and while at the same time improving the microclimate and reducing the danger of flooding. Technically, this is possible through separated pipes for gray and black water, and that means that no water goes into the sewer. The treated water either goes to the growing facilities, as in the picture, or into retention basins in the backyard, as well as the rainwater, where it then can evaporate. The treated black water is used and sold as fertilizer for plants or composted on site. So the remarkable thing about this solution is that it integrates technical, social, environmental, economic, and even spatial factors. The second case, this is what I mean with the illustration of the student and this system here. This is something that is operating at the moment. The second case is basically an urban transformation in a district of Amsterdam, called Bike Slaughterham. Here, 2 living labs were successfully developed according to strict circular principles in long participatory processes. And a third, much bigger plot is now in the making. Unfortunately, after 5 years of implementation, the regulations were relaxed, so they were changed, and the ratio between housing and industry is now was changed from 50% to 50% industry and production to 70% housing, and only 20% is now foreseen for production or businesses. This, of course, raises a lot of questions regarding circularity, because it suggests that a less holistic implementation of CE principles will be the case. So the conclusion here is that it started well, but the closer the realization of a fully circular neighborhood, the less radical are the proposed solutions. And I come now to first my conclusions. So this is basically what I found across the literature and also through my case studies. The boundaries between city and hinterland start disappearing. So when you have a focus only on resources and the resilience of resources, then administrative boundaries start to be loosened. So this has, of course, implications for the governance, but also suggests that, for example, energy can be produced sustainably, and renewable energy may be outside the city boundaries, but still used inside the city center, for example. There's an increasingly nested character of urban infrastructure systems. That means infrastructure systems nowadays are much more connected than they were before. And this is not only in technical terms or in spatial terms, but also in financial and governance capacities. And what I found, which I found very interesting across the 2 case studies, is that the development of those kind of systems was only possible through bending of existing laws and regulations. That means that the municipality often needed to allow things that previously were not allowed in order to make those infrastructure solutions possible. And also in the 2 case studies, there was a large focus on the bottom-up level and on participatory governance, which included citizens and inhabitants, but also a wide range of stakeholders to contribute to that solutions. And this is not a surprise, local data is key. That means what I found is that the more fine-grained the data is for the urban metabolism at the local scale, and the easier it is to create appropriate solutions. And finally, my recommendations so far.
1 minute, Georg.
Okay, that's perfect. My recommendations so far, there should be space foreseen for industry and production inside the city in order to allow for functions that fulfill circular needs. For example, remanufacturing and reuse, but it can also be meeting points, repair cafes, for example. So this is necessary. It is necessary also for specifically for existing cities, and that such maybe former industrial wastelands become free for the functions of the circular economy. What I mentioned already is that there needs to be a certain kind of innovation in policy and governance. So that means silos need to be broken up, and there needs to be collaboration across those boundaries. And what this one example shows quite nicely, and ideally there should be an integration of technical, social, environmental, economic, and spatial factors. So what I have seen is that only a technical solutions that is accepted by the inhabitants is not enough, and that it can work well. So this is what the 2 case studies showed quite clearly. And finally, there needs to be an openness towards future-oriented transition thinking. I think without that, such changes on a quite radical level are not possible. With that said, thank you for your attention.
Okay, let's give George a virtual applause. Thank you for the presentation. Just to remind all the audience that you can just write down your questions to George and all the speakers through the chat on Meet Maps. And later on, we will have the question and answers part, okay? So we will follow to the next speaker now, which is Iván Luque Segura. He will talk us about the urban resilient positive energy districts. Okay, so giving some insights for a user-centric design approach. Iván is a trained building engineer, postgraduate energy efficiency with over 15 years of experience as a project manager in the context of urban sustainability. So he is now currently a research fellow of the ERMIT Europe. Okay, Iván, floor is yours.
Okay, 1 second, I'm trying to connect the presentation. Okay, you can see it now. So good morning, everyone. I'm very glad to be here today in the conference on urban resilience in the context of climate change. My presentation is entitled, as Jose Luis was commenting, Urban Resilient Positive Energy District, where we try to bring some insights for a user-centric design approach. The research developed is framed as part of the Culturally project, which is an H2020 project dealing with plus energy building concepts. And the presentation today is outlined, as you can see here, in 4 main sections, where we will try to go through the cultural and climatic variables within the energy demand domain. We will interrogate on how to integrate the user-centric design approach when conceptualizing plus energy districts. We will go through the main literature, methodologies and tools identified as the energy culture framework. And finally, we will go through the expected outcome and key findings until this current stage. Culturally is an H2020 project which intends to go beyond the current state for nearly zero energy buildings toward a future definition and demonstration of plus energy buildings around Europe. One of the main objectives and results that the project intends to bring is the demonstration of 4 plus energy buildings around the 4 main European climates. The partnership is composed by 17 partners all around Europe with a full range of profiles to support the implementation of the demonstration activities. Entering into the domain of the energy demand at household level, it exists various approaches on the concept of energy user, but a dominant ideal energy consumer is characterized as a persona who is intended to develop functional and rational decisions. This is not the reality, and our findings bring us the concept that academic study has disrupted it through bringing new ways of understanding the nature of building energy performance in order to transform the current situation, the current gap among the performance result outcomes after post-occupancy and the designing expectations. And this will be done through interrogating social practice theories. We understand that cultural and climatic specificities are key to be introduced within the building energy science. And to do so, applying social theories is key in order to understand the behaviors and daily routines for proposing a clear guidance in order to drive successful post-occupancy plus energy buildings. Then social scientific energy research is central to understand the variation in energy use across households, social groups, and societies, as well as the link with energy governance and policy. If we try to define energy use as a conceptualization of the material expression of people performance of everyday practices, we understand that energy demand is an outcome of this energy use, and it can be seen as the nexus of the social practices in which the energy demand is engaged, the time in which they are enacted, and the place in which they are performed. Then a summary, energy demand depends above all in the understanding of the timing and location of a range of interconnected social practices. Then our research intends to allow designers, decision makers and researchers to better define the performing drivers of the dynamics of these practices, to detect the processes that reproduce and synchronize these practices, and also support the definition of the resource intensity of these performing practices, activities. When we bring to correlate the estimated energy, when we try to correlate the building design with the plus energy district concept, we see that cultural factor and climatic areas imply important variation on building performance. And in order to reach this goal, we need to consider and to take into account them from an early design stage of plus energy building, and to understand the correlation among the different buildings within the district. That will allow to create an overriding urban principle, which may have the availability of quickly bounce back to a stable condition and deliver more resilient urban stronghold to cities. That is needed to be done from a user-centric approach through interpreting the real energy demand dynamics of the household practices within the district building stock, and finding the connection and the synchronization and relations among all the buildings and infrastructure within the district will allow to create more resilient ecosystems by the interrelation of all these energy positive elements. But we need to take into account the different scales that are playing at this context. And first of all, we need to recognize that household is a key unit for social organization, which is the base for building a district and city concept. How we try to support the plus energy district and plus energy building design, we are in the process of building a cultural and climatic energy atlas for plus energy building, which is composed by superpositions of data layer from statistical sources, which have a direct impact on building energy demand. And secondly, we have a second layer which bring insights from social sciences perspective on the energy demand, which try to avoid failure in the plus energy building post-occupancy performance. As I said, the platform is baked up in a web GIS tool, which incorporate the different statistical variables in a first group of layers, and this group, this information will be located at NUTS2 level. And complemented by the second layer of information will contain the social sciences analysis of the energy demand dynamics at the household level by interpreting the different categories of the energy culture framework that I will comment in the next slides, which intends to bring characterization of the material conditions, attitude, perception, and social norms, the everyday practices, and the user acceptance of the domestic energy technologies. Energy culture is a framework developed in New Zealand, first of all, but now is worldwide known, and it understand that the energy culture, energy demand, behavior of user can be understood as the interaction between the norms, the material culture, and the energy practices. And it states that the social cultural factor are the one that shape collectively the energy demand and create variations. Then we need to understand, first of all, this level in order to bring up to the district scale. Another methods, studies that we have been going through are the time geography one of time-space studies, where we try to understand the interrelation among the practices and the energy intensity. And that brings interesting insights in how gender is configured within the household. In this graph here, we can appreciate if we go more close to it, how women are more present in many activities at household level, and they are the responsible or the direct managers of the energy consumption in the household. So we need to approach policies and practices looking at the gender scale. Also, we wanted to mention about the flexible concept. We need to understand that flexibility is a key chance that currently is being deployed within the building science sphere in order to allow a better interconnection of energy flows within buildings and households. But we need to understand, first of all, which is the range of practices that are being taken and deployed within the household and at building level, and how these are interconnected, and to understand if these are flexible or not. Then we can understand how practices can be flexibilized, how people is really being a part of this concept of flexibility in order to create a more flexible society, which means to change the daily life concepts and rhythm in order to allow this exchange of energy flows. As expected outcome and key
1
findings.
minute, Iván, okay?
Yes, I'm close to the end.
Okay.
And then, as I said, the energy culture framework allows us to frame a several number of drivers, cultural and climatic, which are affecting the energy consumption, which are grouped in the three main categories. These drivers has been cross-checked with the different statistical data that is going to be allocated in the atlas in order to determine which one are affecting the energy consumption and how, in order to allow the research to bring findings and supporting the design process through identifying which technologies could be combined or need to be avoided, supporting the dimensioning of renewable energy sources and a storage system, fine-tuning the building management system operability protocol and how it interacts at the grid level, also characterizing the comfort level standards and expectation from users, and finally supporting the understanding of the future energy demand in a climate change context. Next step and last slide is the Positive Energy District project within the International Energy Agency, which is the Annex 83, which intends to enhance international cooperation to develop in-depth definition of positive energy districts, which are defined as an area within the city boundaries capable of generating more energy that use and agile, flexible enough to respond to energy market variations through, first of all, improving energy efficiency, secondly, is cascading local energy flows by making use of any surplus, and thirdly, using low carbon energy. Our MIT Europe is currently participating in the Annex 83, and further outputs and research and advice will be developed through this project together with Culturali. Thank you very much for attention. If you have any question, I'm available. Thank you.
Okay. Thank you so much, Iván, for your question. Let's move to the next presentation. As we said, we will have the question and answers later on. Okay, so let's hope that we'll have a large bunch of questions. Okay, so now it's time for Daniel Sánchez Muñoz. He will talk us about electrical grid assessment against flooding by means of probabilistic GIS-based processes. Okay, Daniel is a project engineer from IREC, where he has been involved from several European and industrial projects within the field of automation of water treatment pilots, IoT platforms, and power system resilience against climate change. Okay, so Daniel, floor is yours.
Very much, José Luis, for the presentation. It's a pleasure to be here on the URCC presenting our work. I will share my screen. Are you? It's okay?
Yeah, go ahead.
Okay. So thank you, José Luis. Our work is, sorry. Yes. Our work, the electrical grid assessment against flooding by means of the probabilistic GIS-based processes, is framed in the RESCCUE project. I will give a bit of overview of the project first. Then I will explain what we have developed here, which is risk assessment, cost assessment, and the assessment, the calculation of reliability indices. And finally, I will conclude with conclusions and further work. So first, a bit of overview of the project is in this project, which is it's a European project where 18 partners have participated and take place in 3 cases of study: Barcelona, Bristol, and Lisbon. IREC have carried out the research in these 2, Barcelona and Bristol cities. And in the third work package, which is focused on the hazard impacts and cascading effects. This project has an integrated fluid energy approach. So I will give a bit of impression about what flooding can cause in the cities. So, for example, here you can see the occurrences in Bristol in years 2016 and 19, affecting houses, roads, cars, and having some advantages that, for example, here you can park a boat in front of your house, but it's not the issue here. Also in Barcelona, you can see the consequences of flooding, severe consequences affecting the traffic, roads, the cars, and a lot of things. Huh? But here is the focus of our investigation. This is a picture for the Walham Electricity Transmission Switching Center. Here, the authorities were fighting against flooding during 5 consecutive days, putting barriers, pumping water outside the substation to finally achieve the substation don't collapse. As you can imagine, as the link of the picture says, not much fun when the local substation is underwater, because it can cause serious damages and can leave without energy supply a lot of people that the substation is supplying. So for that, we have assessed the risk. First, for the starting point, what we have is basically the location, the GIS location of the substations, and some flooding layers based on return periods. And what we do is crossing the data. First, we create a sampling layer where we get, which is have a diameter of a study depending on the magnitude of the substation. And after that, we can get different levels of affection. So we get a parameter affected area, as is shown here on the program that this is calculated. And also we get another important parameter, which is the water depth average that is next introduced in a fragility curve. This fragility curve that you are watching here is from the Federal Emergency Management Agency. The good thing here is that the industry, the company that we want to use this methodology can have the historical data to be to model this fragility curve and construct a real scenario of the network. So what we did here also was a sensitivity analysis, and at the end, with the two parameters, we get a final probability, which is categorized in low, moderate, high, and non-acceptable probability. Here you have the summary of the methodology, and this result on this. Here, you're watching the results for both cities studies, Barcelona and Bristol. You can see that most of them are not in danger because it's in the low failure probability, but there are another that could be damaged at some point. So also here in the program, you can see the different stations categorized in the different scenarios that we have studied. We have studied a current scenario and a scenario with climate change. And in green, you can see also the increase of risk provoked by the climate change scenario. We have calculated that by 2100, there will be an increase of risk about 2% provoked by climate change. So going to the risk assessment methodology, we have integrated, for the cost assessment methodology, we have integrated this methodology of cost assessment into the risk assessment using some important parameters calculated on the risk assessment, but also using some open data from the open data portal of the cities. And we have taken everything to calculate 4 different parameters: energy non-supply costs, business costs, auxiliary generation costs, and effective damage costs. And adding all of them, we have the losses related to the grid that at the end in both cities, we are calculating this cost of losses provoked to the grid. And also we can see where is the focus of this cost. So here, also you can see which stations are the ones that cause the main cost to the cities, to the grid in both cities, and also the increases provoked by climate change. Climate change is forecasted to provoke an increase of cost about 20% by the same year study. Finally, the reliability, we calculate the reliability indices. We have taken these 4 that we thought that were good indicators for the grid, and we have integrated these parameters on the same methodology. And finally, we achieved a complete methodology that in once can assess the 3 fields of study. And this allows to calculate the status of the grid for each scenario studied with and without climate change, for the scenarios for the cities studies, and that's it. So As the conclusions for this study is that we have developed a novel method to analyze the risk, assess cost of extreme flooding events in the grid, and also studying grid reliability. And the two main conclusions that we can take from the study is that it's forcing to increase the flooding risk in the grid in a 2% more by 2100, and that translates into cost that means 20% increase, more or less. Further work or investigation is that we are actually developing a tool based on the methodology that I have explained, but also we are improving it because we are adding network analysis methods to increase the analysis accuracy, to have into account more things that should be considered than this kind of analysis. For example, here you are watching one of the results of this improvement. We have taken the whole picture of the Barcelona city, and we linked all the stations, transformation centers, and we have a big picture, a complete picture of the city. And also, we are improving the sampling method. Why? Because the sampling method based on point, first, it's very heavy. So to calculate this in a big area, you need a very good server to run the process. So we are basing the sampling method in area base. So we calculate the areas to achieve achieving also more accurate results. Here an example of that. And that's all. I leave you here some papers published about the methodology from the project, and also the registration of the methodology that we have developed. That's all. Thank you very much.
Okay, thank you very much, Daniel. Just to remember everyone that if you have any question, please use the Meet chat. Okay, and we will make all the questions that we receive later on the question and answers time frame. Okay, so now let's move to Inés, Inés Silva. Inés will present his speech about how to incorporate new challenges and rescue methodology into energy sector. Inés Candido Silva has got the master's degree in forestry engineering, and she has been working in EDP Distribução since 2006. So Inés, floor is yours.
Thank you, José Luis. I'm just sharing my presentation. Okay, I think you all see it. Okay, thank you very much for this opportunity. EDP Distribução, like IREC, is also a partner of the RESCCUE project. So today we are sharing how we incorporate this methodology in our activity. And this is a view from the end user. And how we incorporate new challenges by risk assessment in this context of climate change impacts related to water scenarios. So the agenda is, first of all, we first of all, we have an overview of our scope and sustainable resilience. Then I will explain the rescue methodology. Then the simulation that we made in the network and Lisbon research side, and some new challenges that we have for the future in order to improve our service. So how can we explain our approach in this sustainable resilience? We are in this scope is climate risk preparedness, and we combine the sustainability strategy with the operation resilience scope, which means we include disaster risk reduction and critical infrastructure protection in order to respond and to climate change scenarios. In this sustainable resilience scope, we have 4 main principles. The continuously improve the ability to absorb the impact of events, valuing adaptation and preparation for the response, ensuring the stakeholders' engagement and communication as a fundamental pillar of a business line, develop the ability to proactively manage change, anticipating the moments of transition and evolution of the business model as a source of operations flexibility, and also reinforce the sustainability horizon of electricity distribution system. Here we have just an overview of RESCCUE methodology, and we try to address all the improvements that we made and our own tools that we have to planning the grid, and also our contingency plans that we, when something happen and impact in our grid. So we address this methodology in 2 different ways to increase electrical infrastructure resilience. The grid planning, a new technical solution based on risk analysis and asset management approaches, and also business continuity by improving contingency plans and response capabilities. So our main tool to develop this methodology is a tool that is called the system. It is the D-Plan system. It's a computer system for planning and operation of power distribution network that integrates some functionalities of analysis, automation, maneuvers, restoration, data processing, and communication. And we defined, and this is our decision space to evaluate all the criteria that we introduce in the existing network with new climate variables. So how we apply it in Lisbon's research side as a view of distribution system operation. First of all, just to have an idea what is the network and the grid infrastructure in Lisbon. We have 27 primary substations, and we have this number of clients, and we are in the quality service zone that is the higher quality zone that we have. It's the A zone. So the drivers that we incorporate in the development of RESCCUE methodology were the urban drainage models, and we collect all the historical data that we have and integrate it in the D-Plan tool. And then we have the urban drainage scenarios and try to identify how was the impact in our assets and in our clients. So we just studied the high and medium voltage based on catchment basins J and L model, and this is and it was possible to identify electrical assets that were in the flooded areas. Here we have some photos with the limit of water that that achieved in the flooded events. I must remember that all the grid is undergrounded in Lisbon, so that's why we have this problem. So assessing those areas and searching the available historical data, it was possible to identify the critical assets with flood risk that might be really affected. And in this condition, we have a primary substation and 9 secondary substations. So we moved to simulate how was the impact of in the different components of the grid. We have different scenarios, and with this study, we improve our contingency plans by trying to fit all the consumers and with resource configuration of the grid. So this is very useful for the response for the response in terms of contingency. This allows us also to identify some adaptation strategy and measures, such as fences surrounding the ventilation surface openings and helps preventing similar floods. This is a picture of primary substation in downtown, in Lisbon downtown. And also installed water extraction pumps with adequacy capacity. In terms of integration, environment and cultural heritage, it also allows us to improve our external projection, and those are some examples of adaptation strategy that we implement in our assets. About the new challenges, we also participate in the resilience assessment framework and the resilience as action plan, and we try to decline all this perspective in our grid. And we have new challenges facing now related to energy transition, and we are develop a framework based on these outputs of RESCCUE project. And the objectives are damage prevention and system recovery, also to achieve resilience. This is the same challenge that we had in the beginning of the RESCCUE project, but we have another objectives. Try to find a balanced portfolio of adaptation, because the grid, we have so many assets. We have to have local data to identify where we have to invest our to improve our assets. But also we have another challenge challenge that is related to power system intelligence and flexibility in the low voltage grid. And we are thinking to integrate the dimensions that were developed in the resilience assessment framework, applying it to the grid with more with one or two dimensions more, and there are the physical and technical dimensions, functional, related to
1
our
minute,
service.
Inés.
Okay, Joselie, thank you. Organization, because we have to have an organization resilient to and governance to answer to these challenges, and another dimension for stakeholders engagement and mechanism funding for research and development. So new challenge for DSOs and resilience researches is related to energy transitions. We have to know more behind the smart meters, and when we are planning new infrastructures, we have to include all the decentralized generation and incorporate all the data that we are going to collect. Changes in electricity supply response to natural disaster, how smart and microgrids installation to decentralize the electricity infrastructure and replace the existing grid with more resilient and autonomous power systems. And also there's another challenge that is the regulator's role to pressure and to adopt and prioritize adaptation strategies on businesses' decision-making process, supported on the cost effectiveness of adaptation measures application. We also are worried about insurance companies that starting to impose climate preventing investments to reduce potential climate-related risks of insured assets. And that's it. Thank you very much.
Okay, thank you, Inés. Again, as I have been reminding, if you have any question, please write down on the Meetmas chat. Okay, and now it's time to move to the questions and answers, let's say, session. I don't know if it's worth that I will do it in order, let's say, okay, from the speakers. So I will start with one question to Georg. So it is mainly about how do you propose to overcome the government problem on the urban planning, okay? And also because at the end, as you were saying, there is lots of interactions and lots of agents to become participating together. And finally, who do you propose to be the responsible of such task?
Yeah, hi, back again. So yes, that's a very, very good question. So, and that's a very difficult question also. Basically what I can report is what I have seen in the case studies. And the governance of integrated infrastructures is very difficult because it has quite some complexity in itself, but it also has a lot to do with maintenance, and we have heard about risk management in the last two presentations. So all these components need to be taken into consideration, and usually it's a shared responsibility by utility companies and of course the city in some way or the other, so the municipality. But what I have seen in the Bijkslotterham in Amsterdam, the district development, is that for the first 4 to 5 years in this development, there was a cooperation between a private company and the city leading the whole development. So they were basically organizing all these co-creation events and all the co-working between the different parties. And apparently this is not the case anymore for this next phase. So, and this was a big, so there was a big, uprise by the future inhabitants that will live on this bigger plot, that they feel a bit lost because the city somehow didn't finance this process anymore, and now it's up to the developer. So that clearly shows that there is tensions between private and public parties in doing this. But what I've seen working well is, and this actually also refers to the second case, is a public-private partnership. So the city needs to be open to in some way or the other, to provide capacities for a certain transformation, as well as ideally private development design agency, and then ideally supported by the inhabitants or the kind of citizens. We can't hear you, I think.
Sorry. Yes, thank you for the for the answers. Then we will move to the questions to Iván. Okay. So first of all, I will start with your question, Georg. So it's coming to the conclusions from your presentation, Iván. Did you investigate realize the positive energy districts? If yes, can you just name some of those?
Not really. Within the project, we are now developing, within Culturally, we are now developing the design strategies for plus energy buildings around different climates in Europe, which will be connected at district level with other infrastructures and buildings. That will be somehow first experience of plus energy districts integrating plus energy buildings at residential level. Not many residential buildings having the plus energy concept has been promoted until the current period, but there is a strong, let's say, promotion and intention from the European Commission to promote plus energy buildings, and there is several projects which are dealing with this. Annex 83 from the International Energy Agency is a complementary one, which will be using cases from all around the world, since it's not European-based research collaborative project, and we will have the chance of analyzing the post-performance and the impact assessments at different levels within several cases. Then I would say that I have not myself developed any study on plus energy district, since it's quite innovative approach. The definition of the concept is not yet agreed among the different stakeholders which are part of the policy developments. And then I would say that in the next 5, 6, 6 years, many pilots will come out, and we will have the chance of study how the performance of this concept are being, and collecting all the lessons learned from that process in order to integrate in the 2026 building directive at European level, which intends to incorporate the plus energy building and district concept.
Okay, great, thank you. Then there is some other questions to you. One is, I will read it literally, and then if you understand it, you can answer. If not, we will see how we can do it. It's like which is the potential role of localized smart grids and energy clustering for energy management, and as for instance in association with groups of houses within an hydrogen economy?
Maybe you can repeat exactly, because the last point
yeah, I mean,
is integrating a new concept.
Yeah, at the end is like they are asking also if it's that the way they understand the question, okay? That the positive energy buildings or the positive energy districts and so on can be associated with group of houses with the hydrogen economy. So at the end, I guess that they are talking about creating or take advantage of the hydrogen too as a vector also for that energy thing.
Options there. I don't think there is any barrier or limitations in terms of incorporating technologies. What we see that depends on the cultural and climatic conditions in order to assess firstly if the drivers in the context allow or enable the integration of certain techs. So I would say yes, that is feasible to integrate a group of housing owners or buildings that use specific technologies which are intended to reduce energy demand and CO2 emissions, especially considering the integration of users, which is a much more complex issue than integrating other kind of infrastructure which are having a typology of ownership more less multiple, less condivided. Then I would say yes to that question.
Okay, and then one last question and a comment. In fact, that ones are coming from me. So one is like, how do you propose or you are thinking to take advantage of that positive energy districts or even the plus energy buildings? Okay, how it will integrate with local energy markets, how they will do the energy exchange, and do you think that markets will be decentralized or not?
Yeah, all these questions are quite extensive in terms of discussion that we can reflect about them. The models for economical, the economical models and the co-benefits, how to measure and to balance all the market and business within the energy consumption, exchanges and production within a building or a district need to be set up in a participatory way. Since my opinion is that since users become no consumers, prosumers, they should incorporate new governance models in order to allow market to integrate the new concepts and the new dynamics. I would potentially support a model which incorporate flexible concept which allow direct exchanges of energy and goods among users, but at the same time having kind of an agreement with the grid distributor in terms of providing energy security, and this need to be priced and need to be incorporated within the economic model.
And then the last comment is that I don't know if you are already participating, but as in IREC, we are leading the one group or task group, let's say, within the Plataforma Tecnológica Española de la Eficiencia Energética on positive energy districts, in fact.
I heard something like 1 year ago, something like that. You were coordinating a kind of seminar or sessions where inviting citizens also to, yeah. So I heard that session, that event that you organized, and actually I communicated with one person that was in contact with it, and my idea now that the pandemic has come is also to get in contact with them in order to network and to find synergies where we can
exactly. No, it's more about this, because at the end it's really a, let's say, rising topic, and different views and so on will help also to solve it. So it's just to.
I will be very happy to get in touch with the team who is working on that initiative.
Okay, great. Then I will move to the next questions. There are a couple for Daniel and Inés. Okay. So first to Daniel, there is one probably quite a stupid question, but in fact it's coming from me, but it's why when you are analyzing the risk increase, it's only a 2%, and then when you translate it to cost, it becomes 20. So why that 2% really change that drastically to a 20% on the cost?
Well, at the end, the 2% is an increase of risk, but it's directly related with cost, but there are another magnitudes. So an increase in risk in the electrical network and the substations, you have to consider that the risk is I am in blank right now. The risk is has to be as low as we can. Okay, so I'm really in blank.
No,
Sorry.
okay. I mean,
Yeah.
just it's just something to think. I don't know if maybe it's because it's impacting the most critical zones. So at the end, global energy, or it's going instead of a secondary substation, it will go to a primary, which at the end feeds more and more consumers, more systems, and then the global cost and the impact is larger. But it was just a curiosity, because it's quite surprising that
end,
magnitude change, right?
Yeah, sorry. At the end, they are different curves. 2% in risk means 20 because the cost that is provoking. We are actually measuring different kind of cost. We are measuring the direct impacts of about the substations. We are measuring the auxiliary generation. We are measuring the energy not supplied and a lot of parameters, also the business cost. So at the end, this can be accepted like a synergy. So they are different curves, and it's because the percentages are the magnitudes are totally different.
Okay. Thank you. Then one question to Inés, and then I will make you the question to both of you, because there is one which is just directly asking to both of you at the same time, so you can just open discussion afterwards. So to Inés, is like when you were talking about that thanks to some analysis done in RESCCUE, you realize that you need to install certain heat water pumps, in certain substations or fences around to avoid water leakage and so on. Are you considering also the installation of new sensors, let's say IoT sensors and so on, to increase monitoring of that substations, or it's something that it's not considered at the moment?
Thank you, Georg. Yes, we are considering installing sensors, but also I must remark that our studies, this methodology could be applied in low voltage grid. So here we have a huge investment to do, because we have all the grid of high and medium voltage is automated. So we know, we control very well what is happening. But when we are talking to low voltage, we have another perspective, and automation and the installation of sensors is quite necessary to low voltage. So it's one of the key investments that we could have, but we have to identify the priorities in order to have the related to the demand side, in order to have a balance, like I said, a balanced portfolio of adaptation measures to control the grids and the loads and all that we have to manage in this new energy management approach that energy transition is coming to us.
Okay, thank you. Then the question to both of you, okay, Danny and Inés, is it's from Georg, and it's what could be the contribution of spatial planning to reduce risk or flooding or even electrical grid failures?
I will go first if you want. So the contribution of GIS at the end is that you can first locate all the sensible assets, and once you have located them, you can establish measures, but also with the contribution that Inés already says, that if you can put sensors in the station, and so you can build a digital thing, and at the end is GIS. You can build a digital twin and have in a whole picture defined all the station, the danger. You have forecast with climate, with weather processes. You can forecast which substation can be in danger in some near time. I think it's one of the contributions that GIS can give to the electric sector.
And Inés, do you
Yes.
have a comment?
Yes, as I say, I just enhance the opportunity to improve our contingency plans in the primary substations, and we identify also which components are critical related to the specific scenario. So the context of the local data of these scenarios and this simulation and models that we have access, it's very important to prioritize and our investment, and this is the perspective of grid planning, and also for when the impact on when an event occurs, we can also have the possibilities already study of contingency plans. So we have an improvement of our response and the time of our response in order to reduce some failure or energy supply that could occur. So this is also very important, because we have holistic scenarios. We know the impact of some climate variables, but where are the real impact in our assets? So this is data is very, very important, and this was one of the advantages of this participation in the RESCCUE project.
Okay, let's see if there is any other question from the audience. I think that it's not up to now. So what I can say is thank you everyone for your presentations. I would suggest, to all the audience, virtual applause, okay, to all our speakers. Thank you again, and I hope that you enjoyed really the session, and then feel free to continue enjoying the conference with the coming parallel sessions later on. Okay, thank you everyone for your time, and keep in touch.
Thank you very much, Luis.
Thank you very much.
Bye.
Thank you very much. It was a pleasure.
Thank you. Bye-bye.
Bye.
Bye. Bye-bye.